Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this lesson we are differentiating to find the tangent equation. So we have done lots of work on differentiation and how to apply the basic differentiation of polynomials. Just a key point I want to remind you of what differentiation does for us. Differentiation can tell us the value of the gradient at a point on a curve, but that is also equal to the gradient of the tangent to the curve through that point. Okay, and that's going to be important in what we're doing now. Now, just before we move on to what we're trying to achieve in this lesson, a reminder of what we've already done. So here's an example that we've done previously. Just think through what strategy you would use to solve that type of problem. Well, when you're asked to find the gradient at a particular point, your first step would be to find the gradient function dy by dx, and then what you would do is you would work out the value of the gradient function when x is equal to 3. That tells you the gradient of the curve at that point. Now in this lesson we're going to do questions like this. Can you just take a second to see how the question I've just shown you is similar but different to the one above? Well, in the one above we were asked for the gradient of the curve. Here we're asked for the equation of the tangent to the curve at the same point. So they share some commonalities. In order to work out the equation of the tangent, you will have to know the gradient of that tangent, which you would have done in the part above. So we're going to need both of these steps, but we're going to need additional steps on top of that. Having got the gradient, we're now going to need to state the equation of that straight line, that tangent line. So what we would do is the following 5 steps. The first two are like the one above. We'd find the gradient function, then we'd find the value of the gradient at the point x is 3. That tells us the m, the gradient of the tangent. It's the gradient at that point on the curve, but it's also the gradient of the tangent that touches the curve at that point. So the first two steps will give us m in y equals mx plus c, which is the general equation of the straight line or tangent. But then we'll need to find c, and we can find c because we know the point on the curve x. We will know its corresponding y point, or we can find its corresponding y point. So if we know y, we know x, and we know m, we can find c. So we'll sub in the coordinates x and y and m, find c, and once we've found c, we'll restate our equation with the value of m and c, and we will have done. Now that was all very wordy. Let's just go through a picture of why this works. Imagine your objective is to find the equation of a tangent on this curve. So what you've probably been told is an x value, and you want to find the equation of the tangent at x is 3. So what you'll know is you'll know that this point here has coordinates 3, f of 3. You put 3 into the function to find the y value. And our objective is to find the equation of this tangent in the form y equals mx plus c. So what we're going to do is, if we could find the gradient function and substitute x is equal to 3, that would tell us the gradient of this curve at that point, which is also the gradient of the tangent. So we would have worked out m. Then we know this line definitely goes through this coordinate here, and we'll be able to substitute in the y and the x, the 3 and the f of 3, to find the value of c. So these are our steps here, and that was just a picture to help illustrate what we're trying to achieve. We're trying to find this equation here, and we're going to use some differentiation to work out the gradient at this point, which is the gradient of the tangent, and then we're going to do some algebra manipulation to get it in this form. So let's just do some examples to see it in action. Here's the first one. Pause and have a go. So we're asked to find the equation of the tangent to the curve y equals 8 subtract 5x squared when x is equal to -1. Give your answer in the form y equals mx plus c, where m and c are whole numbers. So firstly, our function is y is equal to 8 subtract 5x squared. Step 1 says we'll work out the gradient function, dy by dx. So differentiate this. 8 differentiates to 0, keep that negative there, bring down the 2, keep the 5, and reduce the power of x by 1. So tidying up our gradient function here, hopefully you see we get negative 10x. So that's our gradient function, step 1. Now, we want to find the equation of the tangent at x is equal to negative 1. Let's work out the gradient of the curve at x is negative 1, which is also going to be the gradient of the tangent at x is negative 1. So step 2, let's work out dy by dx, our gradient function, evaluated at x is equal to negative 1, i.e. substitute negative 1 in here. So negative 10 multiplied by negative 1 gives us 10. So dy by dx at x is equal to negative 1 is equal to 10. The gradient of the curve at that point is 10, so the gradient of the tangent to the curve at that point is also 10. So we can say that the equation of the tangent, let's say it has form y is equal to mx plus c, where m is the gradient, c is the y-intercept. So we already know m, so we can state that m is equal to 10. Now, do we know a pair of coordinates that lie on this line? Well, we do. X is negative 1 is definitely on that line with a corresponding y value. So when x is negative 1, the y value, remember the tangent touches the curve at this point, so they share the same x and y value. So to work out y, we can substitute negative 1 in there. 8 subtract 5, negative 1 all squared. So y would be equal to 8 subtract 5, so y would be equal to 3. So what have we got in this here? We've got a y value of 3. We've got an m value of 10. We've got an x value of negative 1. And that will allow us to work out c. So let's do that. To find c, substitute x equals negative 1, y equals 3, m equals 10. And what would we get? Well, we'd get into y equals mx plus c. So we get ourselves 3 is equal to 10 multiplied by negative 1 plus c. So 3 is equal to negative 10 add c. Add 10 to both sides, we would get c is 13. So we have found the value of c. We have also earlier on found the value of m. So therefore the equation of the tangent in the form y equals mx plus c is y is equal to m is 10, so 10x, and c is 13, add 13. And there we go. That is the equation of the tangent to the curve at x is equal to negative 1, and we're done. Next one, pause and have a go. Okay, very similar idea here, other than the function slightly more complicated. So our objective is to find the equation of the tangent to the curve at x is equal to 1. Our curve is equal to y is equal to 6, add 5x, subtract x cubed. Step 1, we're going to work out the gradient function dy by dx. 6 differentiates to 0, 5x differentiates to 5, and then bring down that 3 and reduce the power of x by 1. So tidying up, our gradient function dy by dx would be 5 subtract 3x squared. So we want to find, though, the equation of the tangent. So we'd like the gradient of the tangent at x is equal to 1. So step 2 is let's work out dy by dx when x is equal to 1. Substituting in 1 here, we get that the gradient of at that point on the curve is equal to 2. i.e., part 3, we can state that m is equal to 2. I.e. the gradient of the tangent. because the gradient of the tangent at the point x is 1 is the same as the gradient of the curve at the point x is 1. Okay, so now let's go over here and say, well, if the equation, the general equation of the tangent is y is equal to mx plus c, and we know m is 2, do we know an x and a y value that lie on this line? Well, definitely, because this line goes through the curve at the point x is 1, so it shares the x and y values at that point. So we need to know the y value. When x is 1, we can work out y by substituting it into the curve. 6 add 5 multiplied by 1, take away 1 cubed. So y would be 6 add 5 take away 1, y would be 10. So what do we know? We know m is 2, x is 1, y is 10. So we can substitute in. So substituting in here, 10 is therefore equal to 2 multiplied by 1 add c. 10 is therefore equal to 2 add c. Subtracting 2 off both sides, c is equal to 8. So we've done it really. We've got that c is equal to 8. We have found earlier that m is equal to 2. Therefore, the general equation of the form y equals mx plus c for the tangent, well, we found m is 2, so it's going to be 2x. We found c is 8, so it's going to be 2x add 8, and we're done. And that's it for this particular video. Thanks for watching.